So next topic we have computer aided process planning, where we are going to see the graph or the particular transmission of the parameters which are in the design to a particular manufacturing guy. So that will be designed by this process planning, how the process route is going to convert into manufacturing data which is in the design data. So which the process planning normally acts as a bridge between the design and manufacturing by translating the specifications of this particular design into manufacturing process details. Normally that we call as a process planning, and which with the aid of computer we are doing, normally that we call as CAPP, computer aided process planning. These are the design approaches for CAP system: retrieval CAP, which is normally called as variant CAPP, and generative CAPP. So there are two basic differences between retrieval CAPP, where the repetitive kind of jobs are mainly done in this particular retrieval CAPP, because it will have the similar kind of design parameters to be done. So there we normally use this retrieval or variant CAPP. Whereas the generative CAP is the one where there is no question of repeating or similar design. They are having different parts to be manufactured by the different machines. So there we can call generative CAPP, which will automatically take the knowledge of doing for the first time, and it is different for each time. Whereas in retrieval, it is having the previous knowledge, and by using the previous knowledge, it will be able to give that particular uh, data to the system. So here we'll see what are these. So general procedure for using one of the retrieval CAPP system. So this is a procedure considering a retrieval process, which is a new part design. So we have a part design which needs to be uh, in the design phase. It needs to be corrected to data which is required for the manufacturing or the end user or manufacturer. So for that, what we'll do, like we'll derive a group technology code. We'll give that particular based on the design or the repetitive or the similar task. We'll have a code, group technology code for that particular part, and we have a search part family. So we are already given that group technology, and we have divided into a particular part family of that particular new part or new component, and we have already given that group technology code which is assigned to that particular part family, and again in that part family it will go and it will prepare the uh, coding system for the part families. Like we have already discussed how a coding system will work for part families in defining a separate part families within the particular group technology. That all that using that course we will already derive that particular part, and we will assign this particular new part in that like in the part family of that group technology. And after that we will prepare a standard process plans for the part families, because we already predefined part families, and we have some particular process plans for that particular part family. So we'll just retrieve that particular process which is already there, and that standard process plan will give and retrieve from standard process plan, and after that we will edit if any requirement is there, or write a new plan, and again it be input for the standard process plan. It will be saved, and again it will be retrieved, and after that it will be process plan formatter. Using that process plan formatter, we have the root sheet which is given based on the requirement of that particular product. So in this way we are going to achieve that process of retrieval or variant CAP methodology. The uses are like we can recall, identify, and retrieve the existing plan, which is, as I said earlier, it is for repetitive or similar kind of designs. So it is very useful in recalling or identifying that particular and retrieving the existing plan for similar parts and make necessary modifications if required. So there is an interactive environment between the planner and the computer, because this is computer aided design. Normally computer is doing this, and the interactive environment will be there, because a planner is the one where the root sheet is having that particular plan in moving from one particular point in a manufacturing cycle to the to a end product. So process planning for a new part starts with the coding and classifying into parts into a similar family, as we discussed in the earlier slides or earlier classes about part families. So normally this particular methodology, starting from dividing that particular part or putting into some particular group technology, we having a part family, and requires the establishment of maintaining a database of standard process plans and content, like all whichever a part you are going to design as a product. So you should have all the database of what all the requirements of tools and processes, and even the operations need to carry it, and all those nodes, data and all that will be taken care of this particular methodology, and requires recall and rating capability. And even if some additional requirement comes in between, you can change or add that particular requirement which is in the editable capability. So this is the example, whereas new part is there and process plans on file is to get a slot. And yeah, in between you want to modify it, so you can remove the slot operation and change the width, which is removing this particular width of this. Instead of slotting, they are cutting over here with the width. So these are the advantages, like you can go through it, how these are, like it is self-explanatory anyway. And the other thing, other methodology, generative, as you know, these are automatically generated by means of or logic or the formula or technology algorithms and all, and it is based on geometric rather than design. Like if you all you are seeing while the CAM, like computer aided manufacturing, is based on this generative CAP methodology, whereas you will be giving some dimensional data or any SolidWorks or like AutoCAD or CNC programming, as you can see. So just by giving that, the mission is going to takes place that particular operation. So it is like that particular logic or decision or formula based or technology algorithm based. Normally we call it as a generative CAP methodology. So this is there are essentially two major components in this. One is geometry based, define all geometric features, as I said before, and even tolerances and locations of the surface units, everything is designed. And knowledge based is like the automatic matching of the part geometry requirements with the manufacturing capability. Like if any predefined part is there already manufactured with you, and the same need to be manufactured for this particular like part geometry, it can be given over here and it can be managed with that knowledge base. So this is a general model. Normally the CAD system which I told, like SolidWorks or whatever the computer aided design, the pre-processors will be there. It will be converting these particular models into the knowledge base of this manufacturing, and that manufacturing will be giving input as geometric thing and the output as a 3D model, and the planning rules which needs to operate like as we discussed. First we need to operate the knurling, sorry, cutting, and then tampering, and then we need to have the slanting operation, and after that we need to have the stepping operation. So there are some planning rules to be operated. So all those particular things will be taken care of this computer CAP model, and of that post processor and production planning and scheduling. So after all this will be taken care, depend on the planning rules and the input and output and the knowledge whatever design you have given for that particular model. So these are the advantages and difference between those two. You can go through it. So benefits for this, like normally the improved legibility and reduced lead time, all these are the advantages. And you know what is a shop floor? Shop floor is the one where you can directly see the flow of materials to the factory which are made. So using this particular whatever we have discussed before, all these will come into picture of this shop floor where we have to manage. So these are the functions of the material flow control. Throughput is nothing but the maximum amount of moving or the transportation of that materials. So here we need to do the scheduling or work forecasting also, and we need to control the quality of that material, and we need to get the capacity feedback, how the lot which was production, after the production, and how it went and all. And we need to do the status monitoring, how this particular flow of the each and every material is going on. And WIP is work in progress, like even we need to track what is the particular work is in progress. All these go all together, we need to do it in shop floor. So these are the three main steps or modules we can say for control shop floor control system, which is order release, order scheduling, and order progress. So here you can see order release and order scheduling and order progress. So based on the priority, this order scheduling is done. And as you can see, engineering and database, this is the normal engineering and manufacturing data which is starting from order release, and this is the first and main step where we can see the route sheets, the material requisition, the job cards, move tickets, and part list. What are these? Like route sheets are the one which gives the information of the particular part to be traveled based on the design what you have allocated to it. So we will decide, okay, from which mission to which mission it should go, and what are the material needs it needs to get that particular thing will be taken care in the material requisition, like tools or the materials, or all those things will come into the material requisition. And job cards are the one like which are related, like which jobs are needed for that for performing this particular operations, that also will be there, like drilling or else like milling, all this like. And even move tickets are the one after completing one particular operation, it should move through material handling systems from one port to other, and based on the tickets of traffic and all, we need to consider that, and will give the smooth tickets. And part lists are the one after in the end we get the part list needs to be there, and after the finished part list it will go to dispatch list. And after dispatch list, based on the priority control, we will order that particular dispatch list to go to the order progress, where in order progress we have work order status report, progress reports, and exception reports. Work order status reports are nothing but suppose I have given a lot of 1,000 mass components to be drilled. So based on the my priority, they will give that work order, like based on these many work orders, they will track that particular status of that work to be identified, and given the reports. And progress reports are the one which the work which is in progress, they will track daily, and in what particular point it is going to like, or else like it is progress, that particular information will see in the progress reports. And exception reports are the one where some errors are having some breakdowns, all those will come into the exception reports. And this is shop floor control. These are the main three things in that. And yeah, this is the order release which I have discussed each and every one. You can go through this and you will understand how this is going to use. And we have the automatic data identification methods. This is simple. As you can see, most of you might be watching this particular barcode readers in any shopping complex or any online purchase. So these will be encoded data or machine reader data or scanner or decoder. This is the principal components of that. So normally with that we can track, or we can have the data of that particular material or any order, for including shipping, receiving, all these Amazons, Flipkart, all this will be following this particular automatic data identification method based on the barcode. These are the types of identification method: radio frequency, magnetic stripes, or optical character recognition, or machine vision system. So these are the four methods normally what we have. So we have these barcodes varying width. So based on this, like the pulse width modulate, or like the particular pulse width is going to change, and by photoconductor we can read, encode that particular electrical signal into binary data, and that binary data will give us the information about that particular thing. So here you can see there is a gap, and you can see the minute over here. These are the coded thing, and based on that the value is 7 over here. We'll see how this value 7 is obtained. So as you can see here, it is divided between the binary data, and based on the black line we are giving that black line as 1 and the null line as 0 over here. And so this is the one which we odd numbers will be taken over here, even numbers will be taken over here, which is manufacturer's code, and the product code will be odd numbers. And the one whichever the code which is given over here will be calculated like this, which is 3 into the 0, which is nothing but this one, into 1, which is 1 minute. So here you can see this 5 into 2 how it comes is because here two ones are there in black line. The same way 1 into 3 is these two ones and this one. In the same way 0 you can see 1 2 1 4 ones are there. In the same way this 0 5 ones are there. In this fashion we will identify the number of black spots and will take that as this is manufacturing code and the center guard leave that, and this is a product code. Now for getting the modulo check character which is 7, what we'll do, we'll trace back this even to here and odd places to here. So first place is nothing but 0 which is over here, and 0 into 1 where the 0 is having only one thing, and next 2 is here 5, so I have taken over here. The same way 3 over here, 4 over here, and 5 over here, and 6 over there. So in this way we'll divide and we'll multiply it into 3 which is for pharmacy. Normally here I consider this as a pharmacy thing. So these are the types of barcode. So 3 into all these characters, and all these characters will give result as 23, and for that, for getting that some coded value which is 7, we are subtracting. So we subtract the result from the next highest multiple of 10. So 10 minus 20, sorry, 30 minus 23 is equal to 7. So in this way there is a particular coding thing for the any barcode, and using that only we are going to manipulate any shopping thing.
You click there and a box
So here is the
appears
system,
here.
how this
E-commerce is a magic trick that
e-commerce
repeats
things
millions
are
of
going to
times a
manage.
day. For a peek at what happens in between, we visited its